In today's lesson, we are going to graph linear inequalities. So we have three objectives. Our first objective is to graph a linear inequality, determine whether the boundary line is solid versus dashed, and then determine whether to shade above or below the line. So let's take a look at this. So first thing we want to talk about is the solution for a linear inequality is a shaded region. It will not be just the boundary line this time. It will be the boundary line plus an entire region that we decide to shade. Now there's two types of boundary lines. There's what we call a solid boundary line, and that's when we have greater than or equal to or less than or equal to. And then what we have is called a dashed boundary line, and that's when we have a greater than or less than. Now for shading, there are four types. So there's a less than, which means that you shade below the line. Less than or equal to, which means you also shade below. There's greater than, which means you shade above. And then greater than or equal to, which means you shade above. Now what I have down here are two examples of graphs. So in this first example, we have a solid boundary line. You notice that it's all together. There's no spaces in between, so it's solid. That means that answers for this inequality can be on the line itself. You notice there's also a shaded section. So that means that any point in this region would be an answer for the graph. Now this is shaded above. How I know it's shaded above is because I put an A at the top, a B at the bottom, and A is on the side where it's shaded. So that tells me we're shading above. Now in this next one, you notice it's dashed. So there are actual dashes on this line, not connected. So this would be a boundary line that is dashed, and that means it does not include any of the solutions. We see that the shaded region is everything below it. Now, I know it's below because, again, if I put an A on the top of the y-axis and a B on the bottom, B is on the side with the shaded section, so that tells me that this is going to be below. Okay, so let's look at how we actually do this. So first thing we're going to do is we're going to rearrange the inequality into y equals mx plus b. Sometimes it's already in that format, so if that is the case, then great, you just go to step 2. If not, you first rearrange it. Then we're going to determine if the boundary line is solid or dashed. Next, we're going to determine the shaded region. So just remember, if it's less than or equal to, it's going to be below. If it is greater than or equal to, it's going to be above. After that, we're going to identify the y-intercept and the slope, and then we'll graph the boundary line first, so solid versus dashed, and then we're going to shade the solution region, so either above or below. Okay, so let's take a look at this. All right, our first example, it is not in y equals mx plus b. So let's use our skills from the previous lesson. We're going to subtract 8x on both sides. So we get y is greater than or equal to negative 8x plus 3. Now, we don't have to divide by 1 because y is already by itself. So first what I want to do is I want to identify the inequality symbol, greater than or equal to. So this is going to be a solid line, and because it's greater than, it's going to be above. The y-intercept is 3, and our slope is negative 8 over a positive 1. So that's down and right, or up and left. Okay, now that we have all of our info, let's actually graph this. So we're going to go start at 3. We're going to count down 8, and then to the right 1. Now we can only make 2 points this time. We're going to connect them with our ruler. Remember, it's going to be a solid line. And then we're going to shade above. Now, what's helpful is we can put A on top, B on the bottom. What side has the actual A? It's going to be this side, so we shade this entire side of the line. All right, let's do 2 more. Oh, nice. This one is already in y equals mx plus b. So we're going to look at the symbol. This is going to be a dashed line. If you notice, you don't physically see a solid line in the symbol, which tells us it's dashed. It's also a greater than symbol, so this means we're going to be shading above. Okay, let's see. Our y-intercept is negative 1, and our slope is positive 2 over positive 5. So that's up and right, or down and left. So let's start at -1. We're going to go up 2 to the right 5, and then we're going to go down 2 to the left 5. You guys are going to take your ruler, and remember it's dashed. So we're going to do dashes, making sure it's very clear that there are spaces in between the dashes. We're going to put an A on the top and a B on the bottom. And we're above, so we're going to shade the side that has the A. So the side that has the A is everything on this side. Okay, last example. So the 4x is positive, so we're going to subtract 4x on both sides. We're going to get 3y is less than -4x minus 9. Divide by 3. And remember, if we can simplify -4/3, we will, but the only thing that goes into it is 1, which means it's still -4/3. So we'll leave it as -4/3, x, and then minus 3. So what do we have here? We have a less than symbol. It's going to be dashed, and it's less than, so it's going to be below. We have -3 as our intercept, -4/3 is our slope. So down and right, or up and left. Okay, so we start at -3. I actually can't go down 4, so I have to use my reverse arrows, not these ones. So we're going to go up 1, 2, 3, 4, and then to the left 1, 2, 3. Up 1, 2, 3, 4, and then to the left 3. So we're going to have a dashed line. Just make sure it's very clear that it is dashed. And then we're going to shade below. Now I put the A on top, B on the bottom. So what side has the B? It's this side over here. So I shaded this entire side of the line.